Okay, Algebra 2. We've had so many calendars, but I'm on the most recent one, May 26th. I had to update it again. Should be the 29th of May, and we're going to review lessons 6, 7, and 8. And what were they all about? They were drawing the sine and cosine waves. So let me start by drawing a sine wave. All right, sine. What does that look like? Normally, if I just said draw a sine, no numbers, I would start here at the origin, and then you would have a up followed by a down, and then it would, I don't say it stops, but that's one wave. That's considered one wave. Now I'm pointing out the 5 points. So it starts and ends, and then there's the middle, and then there's the high point and the low point, and those are the 5 points you need for a sine wave, as opposed to cosine. Cosine, I'm going to spell the whole word out. What does that look like? That does not start in the center. It usually starts at the top if it's positive. If it's negative, then it's upside down, but we're going to say it starts here at the top. And then by the time I forgot to mention this, 2 pi is the normal period. So by the time I get to 2 pi again, I'm going to be at the top. What's going to happen halfway at pi, it'll be at the bottom, and then it's going to cross a couple times. So you see I got 5 points. I don't connect them with straight lines. We'll talk about that more. And I get this cosine wave. Now they're very similar. Hard to tell the difference sometimes between a sine and a cosine, but cosine starts at the top or the bottom, and sine starts in the center, the middle of the wave. And that's how you tell the difference between the two. Now, we've got what I call the ABCs. I don't care if it's sine or cosine. The A, B's, and C's of either one. They both mean the same thing. What is A? That's called the amplitude. Okay. And what is the definition of amplitude? It's the distance from center of wave. Now he calls the center the midline. I call it the center because I like to use the letter C. C stands for center. Center. I'll put midline here just so you understand. If you go back and look at his notes, the midline. All right, so C is the center and A is the distance from the center. Now distance cannot be a negative number, right? If I said how far you live from Catskill High School, you're not going to say minus 3 miles, you're going to say 3 miles. So amplitude is always a positive number. Okay, and then we got a couple other things that we'll talk about when we get to the back of this paper, but we have this thing called frequency. The B is called the frequency. It'd be nice if that was a F instead of a B, but ABCs, we want ABC. So frequency is the B. What is that? That is how many waves between 0 and 2 pi. Notice, by the way, we're always in radians. We're not doing anything with degrees. All right, and then finally, you gotta know what period is. I'll say P for period. Period is the length of one wave. Length of one wave. Now, there's a big connection between these two. And this is what you really got to know about these two things, that the frequency, B, times the period, P, always equals 2 pi. The frequency times the period equals 2 pi. I'm not quite sure. I think he says it a little differently in his book. This is the simple way to memorize it. B times P equals 2 pi. Frequency times period equals 2 pi. All right, we'll come back to that, like I said. All right, so now I want to graph, and then we're going back to the real basic ones that you did, and this would be like lesson 6. All right, lesson 6 just said, hey, I want to graph a cosine wave, and we're going to have an amplitude of 3. The amplitude is 3, so it's going to go up 3, down 3. It's like a dilation almost, right? We're stretching it vertically, like we just did in Unit 7. That's why I had you do Unit 7 before we got to this. So hopefully the two kind of connect together for you. So we're stretching this out. Normally I would start at 1 because it's a cosine wave, but I'm going to start, it would look like this, but it's just going to be stretched out. It's going to be much higher, much lower, that's all. So I'm going to go up to 3. By the time I get to 2 pi, I'll be done. I'll have my full wave. At the halfway point, I'll be at the bottom of the wave. And then between the high and the low, what am I going to do? I'm going to cross the middle. Between the high and the low, I'm going to cross the middle. Some of you got this habit of drawing straight lines, which is really bad because it's a wave. It's a circle. You know, this is the circular function being unwrapped. So just do the best you can, but it should kind of look wavy. You know, sometimes I tell students just put the waves up there first, then connect them together. All right, well that's one full wave, that's a cosine wave. Then I'm just gonna repeat it over here. I'm gonna hit the midline, I'm gonna go all the way down to -3, I'm gonna hit the midline, I'm gonna go all the way up to +3. I'm just reflecting over. So hits again, bottom, hits the center, the top. So there's the cosine wave, keeps on going. You know, keeps oscillating, never goes above 3. Don't do this, don't make it look like a parabola. There's no arrow going up there. It just turns around, comes back down again. So that's a cosine wave. Now you can do it on your calculator. Real quick, I already got it in there. So I put 3 cosine x in my calculator. The mode though, make sure you're in radians, not degrees. So when you graph, you gotta be in radians. And then there's a zoom feature, it's number 7, it's trigonometry. So if you do zoom 7, it'll give you this exact same piece of paper here, okay? If you go to window, you might not recognize 6.15. It's kind of a little bit off, but it's 2 pi. You know, take pi, you double it, you get 6.15, whatever that is, irrational number. So we're going all the way out to 2 pi. And the paper goes up and down 4 places. See that? Up and down 4 places. So this is zoom 7. So this piece of graph paper is zoom 7. So I mean, you could do this kind of cheat and look at it ahead of time, but let's try and practice it. You should check it with your calculator afterwards. So sine, all right, I got an amplitude of what? I know that's a negative, but the amplitude is 2. It's going to go up and down 2 from the center, but the center is 0. And where am I going to go? Well, I'm going to start at the center. By the time I get here, I'll be back at the center. See, the sine wave's a little different. Starts at the center, ends at the center, crosses at the center. Halfway, crosses at the center. Normally I go up, but this is a -2, so I'm going to go down first, that's all. What happened? It's a reflection. And we just got done doing this in Unit 7. You put a negative sign in front of something, it flips it upside down. So that's what's happening. Instead of going up, I'm going to go down. So again, I'm trying to draw waves. There we go. It's kind of wavy looking, right? And then I got to repeat it over here. Now be careful. It's going up. It's going to continue to go up. Then it's going to go back down. And it's going to go all the way down. And then it's going to come back up. Up and down. That's it. Like you're at the ocean. Almost there. Almost to summer vacation. We'll be looking at the waves, maybe get to the beach. All right. So again, if you want to see this real quick, I go to y equals. Let me clear that out. -2, the sine, hit the sine of, just put x there, you can close it, and I'm already on zoom 7, but I'll hit it again. Zoom 7, and I should see the same thing. There it is. Good. All right. Then you got the, I think it was lesson 7, right? We started shifting up and down, so I mean this is a shift. Shift up 2 units. Why? Because there's our center. The center, or the midline, is 2. 2, positive 2. So I'm going to come over here and I'm going to go here. There's positive 2. I'm going to say, yeah, put a little dotted line to help you out. Helps me out, so I would recommend it. Put that dotted line there and you go, okay, there. The wave is going to be in the center right there. That's where the wave is going to be. This is sine. What does sine do? Always starts at the origin. Well, no, it doesn't. I'm going to take the origin point and I'm going to shift it up 2 places. It's going to start right there. Normally, I would be at the end when I get to 2 pi. Well, I'm going to be at the end, but I'm going to be right there. So everything's shifting up 2 places. Okay. The center. And this is a positive. No, sorry, it's a -3. So where am I going to go? I'm not going to go up 3. I'm going to go down 3. So now be careful. Ready? 1, 2, 3. That's how low I'm going. How high am I going? 1, 2, 3, right there. It's going to be trapped between the 5 and the -1. So -1 is going to go down first. Then it's going to hit the center, then it's going to go up to its highest point, then it's going to come back to the center, and it's going to keep repeating. So let me draw the first wave. Okay, there's the first wave. I want to repeat it over here. So bottom, center, now I'm going to get to the top, back to the center, then I'm going to get to the bottom, then I'm going to get to the center. So there's my 1, 2, 3, 4, 5 points again. Now, if you want to put this on your calculator, you can. You just might have to change your window, go up a little higher. You got to make it go up to 6. So you have to adjust your window a little bit, but you can see this. You can graph this on your calculator. Hit zoom 7 and maybe just go up, scooch it up higher to 6 so you can see the wave. All right, what's the range? The highest was 5, the lowest was -1, so that's it. -1 to 5 was our range. Okay. All right, to the back. We're looking for the A and the C. Again, we're not dealing with period and frequency, they're just kind of the standard one. So we're just looking for the A and the C. The C is what you got to figure out first, though. The center. Now look, the highest number I got is 22. The lowest point is right there, which is 6. Where's the center? I mean, just common sense tells you it's going to be like, I don't know, 13, 14, 15, something like that. I had people in the homework giving me negative numbers and stuff, and I'm like, well, no, it's the average of 22 and 6. How do you find the average? 22 plus 6, and you divide it by 2. If you're going to put this in your calculator, you need parentheses around this, but this is such a simple problem. Look, it's 28 divided by 2, which is 14. You don't need a calculator for that. So where's the center of this wave? 14. Okay. And then what is amplitude? It's the distance from the center. So how far is it from 14 to 22? I mean, I don't know. If you're 14 years old and they got a 22-year-old, how many years apart are they? That's all we're looking for here. So just subtract. The amplitude is 22, take away 14, which is 8. There's your amplitude. So we're done. Amplitude is 8. It's a positive 8, by the way. It's going up first. It's a sine wave. And the center is 14. Done. Again, you could put this in your calculator. You'd have to change your window. You got to get up to 22. And you should be able to see this if you change the window and make it go up higher. All right, here we go. Now we're getting to this frequency and period thing. So what is the frequency? Oh, I'm sorry. That's a typo on my part, I think, right? Yeah, no. What's the period? Sorry about that. The period for each of the following functions. Okay. So I got the frequency. And what do we need to know? Frequency times the period is always 2 pi. That's it. Well, 4 is the frequency. So 4p equals 2 pi. I want to get p by itself. It's pretty easy. Divide by 4. I'm done. Well, let's reduce it. 2/4 is the same thing as 1/2. 1/2 pi. Or you can say pi over 2 if you like. But 1/2 pi. That's the period. That's the length of one wave. Okay. So we're just going to repeat this. Make sure you get this. I'm writing down the formula. Oh, this time a half. Half goes there. Half p equals 2 pi. How am I going to solve? Multiply both sides by 2. I'm done. The period is 4 pi. So the length of one wave would be 4 pi. All right, the last one. This one's got pi in it, but I don't care. I'm still going to use this formula. I plug this in for b. Pi over 3 times p. How am I going to get p by itself? I need the reciprocal. 3 pi. 3 over pi. What cancels? Well, the pi's cancel. The 3's cancel. I got p by itself. Over here, though, the pi's cancel again. What do I got? 2 times 3, which is 6. So the length of one wave would be 6. Normal 6. Not 6 pi. Just 6. All right, so finally we get to question 5. And this is the key. I don't say the key, but the big question, I'll say. So I want to kind of put it all together now. We got I hope you can see that. That's a -3 cosine 2x minus 4. And there's a bunch of questions here. There's kind of one hidden because it says what's the period. You're going to need the frequency to get that. Okay. So there's a hidden question too. So let's start with, see, he calls it the midline, but I'm going to put C there. What's the center of this wave? Right there. It's right in front of you. -4. So y equals -4. I'll put y equals -4 because it's a horizontal line. So I'm going to go down. 1, 2, 3, 4 right here. There's -4. I'm going to draw lightly, like a little dotted line. So there it is. There's my midline. That's where this wave is going to be centered. Okay. It's not going to be centered here. It's going to be centered down there. It's moving down, shifting down 4 places. The amplitude is the number in front, absolute value. So if I say, hey, what's the amplitude? You'd say 3. The amplitude's 3. Why is it negative? Because it's going to go down first instead of up first. That's all. All right. Well, let's do that. We can figure out the range. 1, 2. So we're going to go up 3 to -1, and we're going to go down 3. 1, 2, 3 to -7. So this wave is going to be caught in between these numbers. So there's your range. So from -7 to -1, you got to put them in the right order. smallest to highest. Kind of weird. All right, and then finally we get to this thing, frequency and period. I did not give a tough frequency. The frequency is 2, and we know that 2 times the period equals 2 pi. I don't think I have to do much math there. Divide by 2, what do you get? Pi. Pi. So the period is pi. So that's the length of one wave, and this is key on this problem. All right, because you have to scale this. This is not the normal scale. And we want to get 2 full waves. So I'm going to start here. I'm going to just go to the right. I'm not going to do this right and left. We're just going to go to the right. There's 16 lines. I know that because I made the paper. And I picked 16 for a good reason because it's a multiple of 4 and it works out nice. Ready? 1, 2, 3, 4. There's the 4th line. I'm not going to label it 4 though. 1, 2, 3, 4. There's the 8th line. 1, 2, 3, 4. And 1, 2, 3, 4. There's the 16th line. But again, we're not going by ones. I want to go, has something to do with this, pi. Where's that going to go? Right there. Now, why? Why there? Because I want to draw one full wave, and then I want to draw another wave. I need 2 waves. So I'm going to draw a wave, and then I'm going to repeat it and get to 2 pi. Okay. All right, so this is a cosine wave, which would normally start at the top, but because it's a negative, it's going to start down here at the bottom. I picked a tough one. I'm purposely doing a tough one because this cosine's a little tougher than sine, I think. Starting here, by the time I get to pi, I'll be done with one full wave, so I'll be back at the bottom. What's going to happen at the halfway point? What is the halfway point? Pi over 2. Let me put it up above because I think it's going to run into my graph otherwise. Pi over 2 or 1/2 pi. I'm going to be at the top of the wave, and then this is, by the way, this is 1/4 pi, but I'm not going to label that. I'm just going to say it crosses, and it crosses. So there's my 5 points. And the cosine has 5 points. There it is. This is an upside down cosine wave. Take that one, right? I'll turn it. So there's my 5 points. 1, 2, 3, 4, 5. So the one I just did is a cosine wave, but it's upside down. There it is. The bottom of the wave. Top of the wave. The bottom of the wave. Okay? Now I'm going to repeat. So what's going to happen? Well, if it starts here, it's going to end here. And in the middle, it's going to be at the top of the wave. And it's going to cross halfway in between. There's my 5 points again. 1, 2, 3, 4, 5. Same 5 points I just had, just repeating. And it would go on forever and ever. Now, do you want to see this on your calculator? It's doable. Let me try it. Let's go to y equals. Let's clear that out. We got a -3. We got a cosine. We got 2x, close it, minus 4. Now, if I just do zoom 7, I'll see some of it, but I'm not going to see the whole thing. Okay. Why? Because it got compressed. We're doing compressions, stretching and compressing. This got compressed. So if I really want to see the exact same graph, I have to go to my window. And I can say, well, I went from 0 to 2 pi, 0. You can type in 2 pi. And it's all below the x-axis, so I don't know. I got to go from like negative, I'll say -8 to, I'll make the max 1 so we can see the x-axis. Yeah, let's try that. 1 wave, 2 full waves. It's tough to put on your calculator. This is a tough problem. So I picked a tough one. The ones I gave you I think are a little bit easier, but there it is, 2 full waves. But you see I had to change my window to match this. So if I want to see it on my graphing calculator, you have to change the window 0 to 2 pi, and I had to pick negative numbers so it was down here so I could see it. All right, hopefully that will help you. You're going to be doing the independent work, very similar. You know, at the end you got a couple tough ones. Just do the best you can. I'll take a look at it. All right, stay safe out there.